Okay, you can come and plug in. While you're doing that, I will introduce our next speaker. He's worked at Axiom. Axiom are doing analytics, right?
Yes, observability, analytics, like large-scale logging.
Okay, and he's also doing a lot of work on open source. Does anyone use TRPC? Yeah, okay, so he's contributed to TRPC. He's also a marathon runner. And he's going to talk to us about handling obscene amounts of data. So please, are you ready?
Yes.
Okay, so dramatic pause. Please give a warm welcome to Christopher Ehrlich.
Okay, hey guys, so I'm going to talk about performance, and speaking of that, this used to be a full talk, and I've kind of cut it down a bit, but we're going to have to go fast. Performance can mean many different things in like a React app, or replace React with whatever you build front ends in. There's kind of this topic of like web vitals. Does it load fast? Is it interactive fast? There's like rendering performance, but personally, like once you know a couple of tricks, React is usually fast enough, and like all the other frameworks are basically faster. And then there's like this thing of like having huge amounts of compute and like moving it over to WASM. But none of those are like the kind of performance that I deal with most of the time, and the stuff that I deal with, I think, isn't talked about a lot. And that is kind of like handling obscene amounts of data. So I like this tweet a lot. The browser is adding stuff for doing basically that. And people are asking like, why the hell would you do it? So I'll show you like why we need to do it sometimes and how to do it. And even if you don't need to do it, maybe you can learn a few things from it. Let's see, this is going to be tough. If I can find my cursor. So the tool I'm showing, it's the trace. Oh God, there's lag. It's the trace viewer in Axiom. And I don't need to show too much, right? If you've used Sentry or Datadog or any of these tools, you kind of know what this is. You can open spans. You can, like, if one is slow, you can see like how it compares to others. You can expand, collapse, search, all the usual stuff. I guess Michael already introduced me. My name is Chris. I work for Axiom. I do these things that it says on the slide. and so how do you show, and I guess the one thing I missed in the demo is that the number there in the top, it says 1 point whatever million spans. That's the biggest one I could find while I was preparing the slides. We go even bigger. How do you show 10 million of something? And the best answer is you don't, right? And obviously, like that's not that helpful, but I really want to push, like try to avoid it. This takes time. It makes your code difficult to work in. It's easy to create regressions. Stuff you can do to not do it, like pagination, obviously. You can stream in the data as it's needed. Often you don't need all the data. You just need like some aggregate information about the data. So you can do that like in the backend or even better in the database. And then you can kind of negotiate requirements, right? So even as a developer, like talk to your users, and what I find helps a lot is you develop against like a real server that has representative data of how your users see the app, not like this little like migration seeding script that puts like 10 things in. And then finally, like always measure before optimizing, because I don't know about you guys, but like I'm always wrong in guessing where the bottleneck is. But let's decide let's say you have decided to do something like this, right? So here's how we did it. It starts kind of about a year ago now. Our tracing app works great up until about 5,000 spans, but we didn't know that because why would anybody ever like make a trace with more than 5,000 spans? And then here's the ad for my company. We announced like a pricing plan that is super cheap compared to everybody else. And so people realized that they could use tracing like as basically a profiling tool, and they started doing it. And I think like a few days later, somebody said, hey, I sent a trace of this size, like why doesn't it work? And like more and more of that happened. And here's what it looked like. I think you can see from the errors that like this is a failure case that we had not even considered. So like, let's look at what we did step by step to get all this stuff to work. The first thing is the data was going through like a little node server, which was handling auth and a few other things. And We could have probably scaled it. We could have switched it to like Hono or whatever the new thing is. But we realized like it wasn't just going to be an order of magnitude. We needed like 3 or maybe 4 orders of magnitude. So instead, we rewrote how our auth works and started talking to the backend directly. The next big problem we had was that like rendering in the front end just got really slow. That one is kind of the easiest thing. We started virtualizing. If you've never virtualized before, all it means is like you install a library and then like if you have a long list, it renders like the items that are in the viewport and a couple up and a couple down instead of all of them. The second thing here is like if you have that much data, you need to compute derived data lazily. So like if you're virtualizing, but you're still mapping over 5 million things, like that's going to be super slow to start with. And this part was pretty easy, but then like we started hitting this. Who's seen this before? This means basically that Chrome is, or usually it means that Chrome is out of memory. And the rule of thumb here that I have is like, on a good day you get 4 gigabytes, but realistically like you should expect to only get 1 gigabyte. And here's a memory snapshot or heap snapshot. I think the numbers might be too small to see, but this trace has 8,210 spans and it's using 750 megabytes. So we're not going to get to 10 million here. The way I usually use this memory debugging stuff is I just click, like I sort by retained size and then like look at the first thing that's using most of it. Because usually like if you're at that scale, one thing is like using basically all your memory. So I just click in and see what is using it. And in our case, we use MobX for state management, which if you're using Angular, it's kind of like the signals that Angular has now, but like an older version of that. And the way it works is it wraps a proxy around every property of every object, which usually that's great because like then you have a message sending system and only components that use like the nested parts update. When you have 5 million things that each have 500 things in them, that's a lot of proxies. So what we started doing is just sticking the data like in a JavaScript object literally on the window. And we wrote our own little message passing system to know which components need to update. And then the other thing is like long arrays take a long time to find something by ID. So instead we started just keeping an array of IDs and everything else was in a lookup table where the keys are the IDs and the values are the actual spans. But like that works to some extent. But like for our enterprise customers, we let them put, I think, 4,000 something attributes on each event. And you can like basically what you saw earlier, like you can cheat by sticking kind of objects in that are harder to index through. So like these are really big events. But like you can denormalize it, right? If you look at the application, like this red part on the right, that actually like you can scroll all the attributes of the event, so you need the full one. But on the left, you really only need a couple of things. You need like the name, the service name, you need time info to draw that little rectangle, and you need ID and parent ID to create the hierarchy. So yeah, we just denormalized it. We started sending only these little skeleton spans. That degrades user experience a bit, because now every time you need to like see a whole span, you have to make a network request. So we started doing cute stuff like if you hover over a span and like we start a timeout, and then if you're still hovering 200 milliseconds later, we prefetch it. We also started doing things like if you're paging through search results or error spans, like we prefetch a couple in each direction. And then it turns out like even the event handlers kind of become a problem. So a cute thing you can do is you use the data ID and then like you can just use one event handler for all the millions of items. But even with that, right, like at some point the user goes through fast enough and then like they see a spinner. So what we actually do is different behavior based on size. So like if you're doing reasonable things, you get like a great experience. And if you're doing unreasonable things, you get like, a pretty good, but not as good experience. And one example of this is searching. So like obviously if you don't have the whole spans, you can't like search in JavaScript. But it turns out that once you hit a certain size, even with the round trip, like searching in a database is actually faster than doing a full text search in JavaScript. So this wasn't that big of a problem. The next issue we had is mapping over huge arrays. In JavaScript, if you map over an array of 1 million items, like you briefly have 2 million items. And if like those items are your bottleneck, then doubling it is not good. So what we started doing is like plucking one item out of the array, like processing it and sticking it into a separate array and praying that the garbage collector does its thing. One thing I didn't know until recently is shift and unshift in JavaScript are O of n, but push and pop are O of 1. So if you use only push and pop to like iterate over an array, you get it back in the reverse order. But what you can do is send your data in the reverse order, push and pop over it, and then it's right. The next big problem is this is a lot of data and it takes a lot of time to load it over the network. I think this network call here is 50,000 spans, and you can see there's like a bunch of them on top of each other. And the server needs like 1.2 seconds, and just downloading the content takes like 500 milliseconds, and I think the bottleneck there is like my internet connection, which is very fast. But it gets tough, right? So if 50,000 spans take 2 seconds, then you can do the math on what 1 million or 10 million take. It's not nice. The thing that helped us the most is thinking in columns instead of thinking in rows. The first benefit you get here is you don't have to send the word service and ID like 5 million times. But the second benefit that ended up being even bigger is that it turns out like gzip is really, really good at like crunching down the same string repeatedly. And actually like most of the time, most attributes except for IDs and stuff like that tend to have the same values over and over. So like this crunches down the data enormously. One thing we tried that didn't work was we thought like, we'll make like a lookup table of the values and then we only need to send numbers down. Maybe that's smaller. It turns out that actually performed worse than just letting gzip figure it out. Because yeah, both gzip and v8 are incredibly good at dealing with like having the same string value over and over. The last thing in terms of networking is you need to figure out how to chunk your data. So the first thing we did, and I think like this is how most APIs work, right? Like we did the thing on the left because we want to show all the data, so we just get all the data. Currently, we're doing something like the middle, and like obviously the optimal thing is on the right, but like that depends on how you paginate or like how your cursors work. If your cursors are IDs, then you need to know like the last ID to get the next data. But also like at this point, you kind of need to start thinking about how your backend works. So for example, in our case, like the first request that gets the first spans like warms up a bunch of caches, and then like all the other requests go way faster than the first one. That's all in terms of techniques. I think the big thing is like culture, like companies say, oh, we have a culture of performance, we have a culture of this and that. Culture, like it's not what you say, it's what people do and what gets rewarded. So I think what has to happen at times is like, if you have the all hands and you congratulate, like, hey, Bob shipped that cool feature, you need to also say like, hey, Sally made this thing twice as fast, right? Like at least if it was the hot path and like it's an important thing to do. And the other thing here is like, I showed the biggest things that made the biggest difference, but there were also probably like 50 PRs that made like one thing 10% faster. And if you do the math, like if you make something 10% faster 24 times, it's now 10 times faster. So this sort of stuff really piles up and you need that kind of culture. So I think the takeaway is like know where performance matters for you, because like in most places it really doesn't. Improve it incrementally and balance performance and complexity. And yeah.
Amazing. Thank you very much. I think that's another example of hard-won experience, which is now shared with you all. You know, like we all go through these trials where we need to learn these things ourselves the hard way. When we share that information with other developers, at least it's not completely wasted time that's gone into it. We can spread that. We can save people from going through the same thing again.